Hi, Martin and I are doing On Your Own 10.10 on page
345.
345. Thanks for not leaving me hanging. 10.10. Okay. Read the whole thing and then we'll break it out.
125 milliliters of nitric acid, HNO3, with unknown concentration is titrated against magnesium hydroxide with a concentration of 2.3 molarity. If 35.4 milliliters of base are required in order to reach the endpoint, what was the concentration of the acid?
All right. So we have magnesium hydroxide. That's our base. Let's figure out the chemical symbol for that. So magnesium is Mg.
Yeah.
And we find it
in column 2.
2. And hydroxide, of course. Oh, negative. So we're going to say MgOH2, right?
Yes.
Okay. So this is an acid-base reaction, right?
Yeah.
So we're going to have acid plus base equals salt plus water. So we're going to say HNO3. Let's write out our equation so we can figure out our stoichiometry. HNO3 plus MgOH2. Oops, I need another parenthesis. Yields water and our salt, which will be MgNO3. And the NO3 will need to have 2 of them for every magnesium because they only have a single negative charge. That's, of course, nitrate, the polyatomic ion. All right. So we need to figure out what again? The concentration, the molarity of the HNO3. Okay, so here's what we're trying to find. All right, so we have a number of steps to go through. We know that we have 35.4 milliliters of this. Okay, now in the previous problem, we remembered that, of course, molarity equals the number of moles per what?
The number of liters.
Number of liters. And we happen to know that it's 2.3 per 1, right?
Yeah.
So we're going to use that to figure out how many moles of magnesium hydroxide we have, but let's convert this into liters so that we're working with the correct units. So that's going to be times 1 liter per 1,000 milliliters. 1, 2, 3, right? So 0.0354 liters. Okay. So just like we did in the other problem, we're going to multiply this molarity. Because in order to get the number of moles, it's going to equal the molarity times the number of liters, right?
Yeah.
So the number of moles, where am I? 2.3. Which is moles per liter, right?
Yes.
Times 0.0354 liters. And that will cancel liters, and give us moles. So now please do the handy-dandy calculator work for us. And multiply 2.3 by this and report it to 2 significant digits because we're limited to 2.
Times what again?
2.3 times 0.0354.
4 equals 0.08.
0.08. And that's what?
The molarity.
No.
Moles.
Moles. Okay, so 0.08 moles, right?
Yeah.
Again, we're using milliliters, so it's not surprising that this is a small number of moles. Okay. How many moles of, oh, is this balanced? Let's check that. It's not, of course. We need 2 of these, right? So we have 0.08. I'm sorry, we need 1 more digit.
Okay.
These 2 are not
Don't worry, I
significant.
still have it here.
Great.
1.
Thank you. Okay. Yeah, those 2 aren't significant, so we need 1 more. So 0.081 moles of MgOH2. Now, how many moles do we use? It's 2 to 1, right?
Yeah.
So this is going to be twice the number of moles, right? So we're going to multiply this by 2 to figure out how many moles of HNO3 are we using, right?
Okay. And that gives us 0.162. Want more? Actually, 0.163.
No, it doesn't. You multiplied the wrong thing. You multiplied the answer that the calculator gave you instead of the significant digits we're using. I'm sorry, I'm just going to adjust my camera slightly so that what I just wrote on the board is visible.
162 then?
Yes, 0.162 moles.
Okay.
All right, so if that's the case, the number of moles per number of liters will give us the molarity, which is what we're looking for, concentration here. So this is how many liters. Let's convert this also to liters. 1, 2, 3. So it's 0.125 liters. Okay?
Yeah.
So the molarity of this is going to be 0.162 moles per 0.12. Well, that would be nice if I could write what I'm saying. 125 liters.
0.162 divided by 0.125 equals 1.296. And that's the molarity. That's the concentration.
Right, and we have 3 here, so we're going to say 296, you say.
Yeah.
1.30 molarity. All right?
Right.
High 5. Come, give me a little boogie. Give it up. Get over here. Little chemistry dance.
Little chemistry dance. You cannot stop me.